Let's talk about what makes deep learning actually deep. I know it sounds mysterious, almost like there's some secret sauce hiding inside these neural networks. But the depth is actually all about layers. More specifically, it's about stacking lots of hidden layers between the input and output of a network. Traditional neural networks? They might have one or two hidden layers, just enough to do basic pattern recognition. But deep neural networks? Think 3, 10, or even hundreds of layers packed together, each one building on the last. Some modern models even top 1,000 layers. The point isn't just to make things complicated for the sake of it. Each new layer gives the network a chance to transform and refine the data, teasing out more complex features as it goes. Here's where the concept of credit assignment path, or CAP, comes in. It's a fancy way of saying, how many steps does the information have to pass through, from input to output? In deep learning, that path is long, often way more than 2 steps. And the deeper the path, the more subtle and abstract the features the model can learn. That's why deep networks absolutely crush traditional ones when it comes to things like image recognition, speech, or even generating language. But, and there's always a but, this depth comes with a price. The deeper your network, the more data you need. I'm not talking about a few spreadsheets here. I mean millions of examples. It's like teaching a child to recognize every dog breed on Earth. They'll need a lot of photos. And because there's so much to process, training deep networks takes a ton of computational muscle. Hours, days, sometimes even weeks. That's why GPUs, those beasts built for crunching numbers fast, have become the workhorses of modern AI. Now, here's the magic: researchers have found a scaling law. It's shockingly simple. If you add more layers and feed in more data, and you've got the hardware to handle it, your model just gets better. Accuracy goes up, features get sharper, and suddenly, problems that seemed impossible start looking solvable. This predictable improvement with scale is a huge part of why AI has advanced so quickly in recent years. So, in a nutshell, the deep in deep learning is all about stacking layers to unlock more powerful, nuanced features in your data. It takes a lot of data, computation, and patience, but the payoff is models that can understand the world in ways we never thought possible. That's why the global race for bigger datasets and faster chips isn't slowing down anytime soon.